Welcome to Mesh Analysis using KVL and KCL, problem 2. In this problem we have two current sources. We have a 2 amp current source on the left and a 1 amp current source on top, and there are 5 resistors. So what we're going to do is start this problem by drawing the mesh currents. The mesh currents take on the current direction of the current source. In this problem it's pretty intuitive. The current source just gives us the direction of the current, and in both cases they are clockwise. What we don't know at this point is the voltage drop across the current source, so there will be a voltage drop across the current source, and we'll find that out as we solve this problem. So by inspection, our loop current in I1 is 2 amps. Our loop current for I2 is 1 amp. And the question now is, what is the current going through R3? So by KCL, at node A, we have 2 amps coming in from the left, 1 amp exiting on the right. So the remaining current is 1 amp going down toward R3. At node B, we have 1 amp coming in from the right. There is 2 amps exiting on the left and 1 amp coming in from R3. The voltage across each component can now be calculated. There's 2 amps going through R1, which is a 10 ohm resistor. That gives us 20 volts. There's 1 amp going down through R3. That gives us 100 volts. And there is 2 amps going through R2, giving us 50 volts. The current through R3 was found using KCL, allowing us to find the voltage drop across R3. And this applies to both sides of R3, so in each mesh section. Now we can find the voltage drop across each current source. So for loop 1 we have 20 volts plus 100 plus 50 will give us the voltage drop across our current source 1. And from loop 2 we have 50 volts plus 75 volts minus 100 will give us the voltage drop across our second current source. That's pretty much it for this problem. We can check this against the simulation. So PSpice gives us 2 amps on the left mesh and 1 amp through the right side of the mesh, and 1 amp down through R3. It's always a good idea to practice as many problems as you can that you feel comfortable with, and to check against a simulation if you have a simulator handy. Thanks for watching, and if you'd like to go on to problem 3, give it a shot. I'll see you in the next video.